So this is what we're going to kind of do today. We're going to talk a little bit about how to tell problems apart, a little bit more of that. Not enough. We'll do more in the study session. I think we're not going to get to very many today. We'll only do a handful between 10, 11, 12, and kind of some other ways of how to tell them apart. And then we're going to go talk about a little bit about problems people missed quite a bit on chapters 7, 8, 9. And then we're going to do a little bit of review of chapters 1 through 4. Today you have due Connect Math 11-2 and also Project Lab 10, late for full credit. So the data for that is in Canvas under Part 1. And also make sure you read the directions before or while you're watching the video. It just makes things a lot easier. It makes more sense. Sunday you have 11.3 due. That's your last homework of the semester. Since this is our last meeting of the semester, I don't know, it went by so quickly. The other thing is the file's going to be grouped, it's going to be about 35% on chapters 10 and 11, heavier on 10 and 11 because the exam 4 is rolled into this final. And the rest will be about 20% on exam 1 material, 20% on exam 2 material, and 25% on exam 3 material. And it's going to be grouped by exam. So this is what that means. So it means that I'm going to give you exam 1 material, maybe within that first, something like that. So it'll be mixed up, whatever, between the chapters, but it's all going to be exam 1 material. And then exam 2 material. Within exam 2 will be mixed up, but it'll be all next. And then exam 3 material, and then exam 4 material. Or you might have the version where it goes the opposite. You have all the exam 4 material, and then all the exam 3 material, and then all the exam 2 material, and then all the exam 1 material last. So it'll be one or the other, but it's going to be linear like that. So you don't have to worry about it. Well, wait, was this chapter 3 or was this, is this a hypothesis test? You don't have to worry about that part because it will kind of go in order. So that should at least make things a little bit easier so it's not quite as overwhelming to kind of help you group things and sort things out a little bit. Okay. The other changes for this is that you have to upload your work, all of your work, because that way I can give you partial credit, and I wasn't able to give some people partial credit last time because I didn't have their work. Upload all of your work as one PDF file. So take pictures with your phone, save it as one PDF. You can do that with Cam Scanner on Android or the iPhone, and you can also do it with Notes on iPhone, and there's videos on how to do that on Canvas. And also, you have to log into the class Zoom before your final in order to access the final. So let me mute this. Oh, I can't mute me yet. Great. So we're going to talk about that a little bit right now. Who hasn't read in a while? Rosa, have you read recently?
I can read. I don't.
Or I can make someone else read. Austin can read.
Material and start the test. Once they are in, I would disconnect them from the Zoom meeting and let the next group, let in the next group. You may enter Zoom starting at 10 minutes before your official exam time, and you'll have 180 minutes to complete the exam once you begin. Zoom into our regular class Zoom meeting. If you have any problems during the exam, I will be available in Zoom.
Perfect. Great. So yes, I'll be available in Zoom. Just come see me there. And you also have to Zoom with me in the beginning in our regular class meeting. So you can start that 10 minutes before. So this is what you need to do. You're going to Zoom in. Oh, where'd I go? There you go. Right, now you'd be like, oh, hi, Ms. Young, how you doing, right? And then I will start you up so then you can access Proctorio. So then you're going to show me your computer screen, and it'll say, oh, see, here's my computer screen, and here's, everything else, and there's nothing, funny going on there. And then I'll put you into Proctorio, and then you're going to pick your phone, and you're going to put yourself way out of reach, so it can't so it's way over there. And then you're going to go ahead and sign into your Proctorio, and then you'll do your little room scan and all that other stuff, right, and all that. And then you'll go ahead and start your test. And then I will, once I see that you're in and I've kind of confirmed that you've started the test, because I can tell that sort of stuff, then I will, this is a problem. I forgot. It always happens, I forget about that. Then I will I will disconnect you from Zoom. And then once I disconnect you from Zoom, then your phone will go, dead and quiet, and it'll go back to this thing here where, it's just blank. And then it'll, go to sleep and whatever, and it won't use up any battery. It'll just kind of, fade on out.
Yeah.
Yes.
You're muted.
Oh, crap.
Sure.
So sorry.
Then you ignored my messages, Miss Young.
Yeah, I see them now. I saw them starting to come in. Right. So after I've confirmed that you're in, and I'll turn it off, then your phone Zoom will go off on your phone, because I will kick you out of the meeting, and once I kick you out of the meeting, then it'll kind of, go to sleep sort of in a sense, and it won't burn up your battery, and you can just finish your test, and then your phone should still be fine and should still have battery life and everything else, and you can take your pictures and upload them. Okay, great. Good. Any other questions? Any questions? No? Everybody's good? All right. Here's the final and what it covers. Chapters 1 through 11. You're allowed 1 page of notes, both sides, and all your tables. T-table, PPMC table, chi-square table. If you want a Z-table, that's fine too. Your magic formula sheet, and your TI calculator. Mac users, make sure you turn off pop-ups so you don't get kicked out. PC users, make sure you restart your computer. That's not the same as turning it on and off. The restart will clear your memory. And then also don't forget you have to upload your exam work pages as one PDF file in assignments. So I've moved it. It's in assignments now. It's not in quizzes anymore. I moved it over to assignments because that is apparently a better place to have people upload stuff. So if you go to assignments, there'll be one that says upload final, which probably is not available yet. It will be available next week. And you just save your work as one PDF. It will only take a PDF and only one. So upload them, save them as that, and upload them. And again, directions and videos on how to use Cam Scanner or Notes in order to save it as one PDF are on Canvas. Questions? No questions?
Oh, sorry.
Yeah, go ahead. Question. Yeah?
I have a question about the calculators that we borrowed from you from the beginning of the semester.
Brilliant question. Yes. Okay, so there's 2 different ways you can do that. 3 different ways you can do that. 1, you can bring them to my door, knock on the door, like where you work it out with me, let me know when you're coming, and then I will, you can leave it, and then I will back away, and then I'll put money down, and then you can back away, or whatever, I'll back away, and then you can get your money, and then we're good. Or, if you'd rather go to campus, you can turn it in at campus in security. I can put your name in there, and then they'll check you off the list. Or actually, I'll see when you put it in, because it has it has the code on the back, the A whatever or the B whatever. And if you have, and I can Venmo you, so I'll have to Venmo you. Or if it's a check, I'll tear up your check and I'll send you a picture of the check. But if it's cash, then I probably have to Venmo you. Or if you want, you can leave it on my doorstep and I can Venmo you. That works also. You just have to tell me what to Venmo you on. Third, you could wait until next semester and the fall, and then you can turn it in then, and we will mostly be online, but we will be allowed on campus, I believe. So you could probably drop it off at my office then, or we can find time to meet at the office at some point. So that could work as well.
In order to submit or get your address somewhere.
Yes. Yeah. So it's on Canvas under, if you go to the important info, you know, XW and pass not pass and where to pick up handouts, my place is where to pick up handouts. So it gives my address and it tells you kind of directions how to get there and stuff like that.
Okay, I'll email it after the final and then we can,
perfect.
I'll be there.
Cool. If you borrowed them from the map department, then you turn them in to the security. And security has a big box and a place to check off, and you put them in there. And I think there's a number as well, but maybe they have to check off your name. I'm not sure exactly, but that's where you do it for there. The library calculators, you turn them back into the library, and I will email the librarian, email me, and I'll email the librarian and say, how do I turn this back in? And probably you just need to do that. You know, they're open over the summer, so you can probably do that over the summer somehow, because the library will be open at some hours, and you should be able to turn them in some way, shape, or form. And I don't know whether, I don't know. Email me, and we'll figure out the details. Good questions. Nice. All right, so again, these are the problems to study for the study guide, for the final, from each study guide. And these are my Zoom office hours next week. Right, so Tuesdays are the 2 review sessions from 3 to probably go to 4:30, and 7 will probably go to 8:30. The first hour is going to be, I'm going to have it kind of planned. I'm going to work a lot on how to identify the problem. I'll probably do 20 minutes of that, and I might talk about how to do it for 10 minutes before that, so that'll probably be the first half hour is just how to tell the different problems apart. And then we'll probably do a handful of problems that I've prescribed, and then probably the last half hour or so, I will open it up and see if you guys have questions that you want specifically, like, you know, can you do problem blah 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 from study guide blah blah blah, and we'll do stuff like that. So the first hour will probably be the same between them. The last half hour might be different. And if you have other questions, you can always ask me questions Monday or Wednesday, or if you need to meet and discuss things, you can come Monday or Wednesday, or you can meet with me at other times. Just email me and we can work it out. Okay. So on the study guide, so study guides on your Canvas, when you go into Canvas for our class, if you scroll almost all the way down, there's this, towards the bottom, is this study guides, practice exams. And the solutions are there. If you click on that one, then you will get to this. And the very bottom, these two at the very bottom, I've added this second to last one because it used to be something I handed out in class, but obviously we're not meeting. And this is really important. It's 4 pages of problems that you don't do the problems, just identify the problems. Figure out what kind of problem it is. And then below that is the solutions to what kind, it tells you, so you can check your answers and see if you got those right, because that's really important to be able to identify the problem. That was one of the biggest problems people had with exam 3, was they would do a hypothesis test when they're supposed to be doing a confidence interval, or they'd be treating it like a mean when it really was a proportion, and you lose like most of the points. Like some people lost all the points, depending on what the problem was, and that's just at least half the points. Usually more like 3/4 of the points. So it's painful and it costs you a lot when you make those mistakes. Lab 10, again, the instruction file is under project in Canvas. Data is under project part 1 in Canvas, not 2. That's a typo. And then videos videos that the instructions I gave to my class last semester, that's kind of blurry. So you want to probably read the instructions, the directions first, and then follow along in Excel and Canvas as you watch. That'll make the most sense. And then also, some people had some issues on Tuesday, so I did a video on Tuesday, which I emailed out to you guys, I believe, on Tuesday, and that has me going through it in Excel, which I think will be helpful as well. And then at the end, you want to email me your Excel file or your link to the Google Sheets, and you're also going to email me your PDF of your hypothesis test and questions. And you can do that all in the same email. You can, attach both files, or have a link and attach the PDF. But I need one PDF that you're going to be doing a hypothesis test by hand on a piece of paper, right, and answering some questions afterwards. And just take a picture of that page or pages and save that as a PDF and upload that to me. So those are the 2 things I need: the Excel file or the Google Sheets file, and the PDF. And you can just do a link to Google Sheets, that's fine, it's no problem. All right, let's talk about reviewing Chapter 10 and 11. So Chapter 10, that's the correlation coefficient one, where you're comparing R to your critical value, and you're kind of using R as an estimate of rho. Rho is your population correlation coefficient, and since we don't have that, we're going to use R, our sample correlation coefficient, to see and use that as our estimate for rho. So here, our correlation coefficient in general, they range from -1 to +1. That's the range. The lowest it can be is -1. That is a perfect line with a negative slope. +1 is a perfect line with a positive slope. In the middle, 0 is no linear relationship at all. That's just a bunch of scattered dots like these dots here, where it kind of makes kind of just a big O, a big circle. There's no direction whatsoever. Okay, good. So that's it. And then let's take a look at the next part. You're going to be doing, I should talk about this. So what you're going to be doing is getting your PPMC table. So this is kind of, maybe I should go in order. So the first step you're going to do is going to be your H0 and your H1. Right? So H0 is going to be rho equals 0. H1 is going to be rho is not equal to 0. And we'll talk what that means. Again, H0 is no, in this case, no correlation, no line, equals. Okay. The second step is going to be this critical value. So you're going to bust out your PPMC table. Right, and you're going to use your degrees of freedom. It tells you actually how to find degrees of freedom right up here, n minus 1. And you'll figure out your degrees of freedom. It's the number of pairs is your n, minus 2, n minus 2. Find your degrees of freedom, and then your level of significance, and that will give you your critical value. Then once you do that, you're going to draw this line. You're going to put in your critical value here and shade to the outside, to +1, and you're going to do a negative of that same critical value, and you're going to shade to the left, to the outside, to -1. And then you're going to find your R. So when you find your R, you're going to put your R in wherever it is, right? So figure out where your R goes. If it's over here, this is in the guilty range. So you're going to reject H0 if it's over here. If it's in this middle range, this clear range, unshaded range, you're going to not reject H0 because this is the not guilty range. You do not have enough evidence. But if it's out here in the shaded range on the left or shaded range on the right, you're going to reject H0. How do you find R? You're not going to worry about this big long formula. Instead, you're going to put your x's in list 1, your y's in list 2, and you're going to do stat test, Lin-Reg t-test of L1, L2, and round to 3 decimal places. Then you're going to do step 5. Well, step 4 we talked about it again, right? Reject or not reject based upon where it's guilty or not guilty. And then step 5, I am totally fine with you just using this blank enough evidence of a correlation between blank and blank. So this is your X and your Y, whatever they are, casino size and revenue, or number of cars and income, whatever. And then this part here will either be enough evidence or not enough evidence, depending upon whether or not rejected H0. If you reject H0, then you do have enough evidence. If you do not reject H0, then you do not have enough evidence. Okay, good. So those are the steps. So let's talk a little bit about the second part, which is predicting. So the first part I'm going to ask you to do is a hypothesis test, steps 1 through 5. The next part I'm going to ask you to do is I'm going to say, predict the Y for this X, for some X. So here, remember, H0 is no correlation, no line, null hypothesis always knows, no line, no correlation, no difference, it's equal. If there's no line and no correlation, then you don't use, it doesn't make sense to use a line to predict. So for example, we all agree that there's no correlation between your height and your test scores. So my best guess for someone who is 5 foot tall is, my best guess at their test score is whatever the average test score is. So the average, the y bar for the y's, the average y's, or the x bar for the x's, the average x's, is your best predictor for those. That's the best number to use to predict. Whatever your y bar is, your x bar is. If you're talking about the y's, then you use the average y. If you're talking about the x's, just use the average x. If it is a line, if you reject H naught, then it is a line. And in that case, there is a significant correlation, and then you'd use this y equals a plus bx to predict. So you might say, well, where do I get y plus equals a plus bx? From Lin-Reg t-test. That'll give you your A and your B. So this is the second part. The first part was the hypothesis test. This is going to be the second part. Same with the lab. And again, you only use that line if you reject H naught. If you do not reject H naught, then R is not significantly different from 0, then you just use the mean. So how do you find y bar or x bar? 2-bar stats. So you're going to put you have your x's in list 1, your y's in list 2, and you're going to do a Lin-Reg t-test here, for example, and here my p-value is more than 5%. It's not unusual at all. I'm not going to reject H naught. So in this case, I would not use the A and the B, right? Because my p-value is larger than 5%, which means my R must have been close to 0. Instead, I'm going to do this 2-bar stats. So how do we do that? You're going to go to, you have your data in list 1 and list 2. You're going to go to stat, and you know what? We'll go ahead and go through the whole thing. So I'm going to go to stat test, go up to Lin-Reg t-test, enter, and it's going to be L1 is my x's, L2 is my y's, frequency is 1, or if you have a fancy calculator, just leave it blank if it asks for a frequency list, not equal to, leave that other one blank, and calculate. Okay, so then it'll give you some information. It gives you the A and the B. If you arrow down, it gives you R as well. Okay, if you need your Y bar, you're going to go to Stat Calc, 2-bar stats, and you're going to put in L1, second 1, comma, second 2 to get L2, and then that will give you your X bar and all this other stuff about X. And if you arrow down, it's going to give you stuff about Y as well, which is super useful. So then that gives you your Y bar without you having to calculate it any other way. Okay, so that was chapter 10. Where do you get the Zoom code for the study sessions? The Zoom code, it's just my regular office hours. So if you go to my office hours, it is, so if you go to Canvas under office hours, Zoom office hours, and Zoom office hours and Zoom classes, then it's right there. It's also the same one that the same Zoom code that you did your 10-minute interview with me. It's the same one. Okay. So if you have the access to that file, you can always get back there. It should still be in there as well. So 11.1, now we're into chapter 11. The first one was the chi-squared list, right? So this is the goodness of fit test. So this one is where you have data, you're given a list. Here, I'll show you it. It's this one here. So you're given a list, and it's categories. Maybe I'll go back. Let's talk about this a little bit. So chi-squareds, all the chi-squareds, they're going to have observed, which they give you. You're going to have to calculate the expecteds. So yours going to be given observed. Yours got to calculate expecteds. Also, they're going to be where your data is categories, not numbers. So previously, with the with the x's and y's, your data is numbers. What's your test score? What's your height? I'm not going to say, oh, my height is blue, or my test score was Neptune, right? They're numbers. Here, the answers that people are going to give you are going to be labels, categories, and then you're going to make tally marks and counts of frequencies for how many are in each group. So, for example, this one, last time we had one about there's one about Mondays, Tuesdays, Wednesdays, what days of the week, or what flavor is your favorite? What's your favorite soda flavor? So you might say orange. I'm not going to say, oh, what's your favorite flavor? Oh, 7. No, it's going to be a color, and they're going to make a tally and keep track of how many say orange, how many say grape, how many say cherry, and stuff like that. So then we're going to give you the observed, you have to compute the expected, and then you have to write them out. So the chi-squared, let me go ahead and give you the O sub I and the E sub I. So step 1, people kind of want this. Step 1 will be the H naught. Ooh. I'm going to try typing it. We'll give it a shot. H naught is O sub I equals E sub I, and H1 is O sub I. Ooh. O sub I is not equal. Yeah, good luck with that. E sub I. All right, let's try this. See how it goes. First, let's move it. Not equal to. That was bad. Oh, okay, that's better. Okay. There, that's a little better. All right, so that's my step 1. Step 2 is find your chi-squared. Find your critical value, excuse me. Find your critical value. Step 2 is going to be the critical value. And then you're going to draw this little loopy thing like that. You guys remember? And you're going to shade off to the side and put in your critical value. Remember, this one always starts at 0 because these can only be positive. You're adding numbers that are only positive, so you're going to get a number that's positive. So it can only go in one direction. So it's always going to be greater than 0. So it's always going to be only right-tailed. Step 3 is going to be this whole critical value thing. God, I can't talk. I must be tired. Step 3 is going to be finding your chi-squared. So you're going to calculate your expecteds, and then you're going to do this whole thing where you do every observed minus the expected squared over the expected. And you're going to add them all up. You do not need to physically add them up this way. You can use your calculator if you want. Some of your calculators will be fancy and they'll have a goodness of fit chi-square GOF test. You can totally use that. That's fine. But you still have to show me, everybody has to show me these numbers written out with the formulas for this step. Why? 2 reasons. 1, that I know you know the formula, and 2, then you don't have to do it for 11.2 because it's the same formula, only a lot more of them. This one's only going to have 3 or 4 of them. So prove it to me here, it'll be easier. And then you're going to write in whatever it is, and you're going to put it in, wherever it goes in here. And then step 4, again, obviously if it's in this range, you're going to reject H naught. If it's over here, you would not reject H naught. And then the 5th step is fifth step for this one. I'll go ahead and type that out because it is a little bit different. You can just use the one you used for 11.2, but this one's a little bit nicer if you do this one. So there's either blank evidence, either enough or not enough evidence that the proportions are as stated. So that's the step 5 for this one. Oops. blank evidence that the proportions are as stated. And again, if you reject H0, then there is enough evidence. If you do not reject H0, then you do not have enough evidence. Okay, questions about this one? No questions. That is 11.1. So here's an example of 11.1, for example. All right, so here we're not given a table, we're not given a matrix, we're just given words in sentences. And in fact, 11.1 is the only one where you're going to be, of chapters 10 and 11, it's going to be the only one where you're given it in sentences like this. And you may not you may get a table on the exam. There's a good chance you get a table on the exam, actually. But at any rate, you're given the observed, and then note that it's either going to be proportions or percentages. See how this is a percentage that I'm giving you? That's totally, anytime you have a percentage, that's got to be one of the chi-squareds. It's either got to be the chi-squared. In fact, it will always be the chi-squared list, because the other one, you don't even compute, you only compute the first and last expected, and you compute them off of the matrix. So this is going to have to be, if it gives you a percentage, it's got to be a chi-squared list. At any rate, it won't always be a percentage though, because either you're going to be given percentages, and you take each of the percentages and you multiply by n to get the number in that group. So 60%, 6% of 300, multiply by that to get the number that should go into that reusable shopping bag. That's your expected value. Or, for the expected value, we'll say equally likely or no preference. Those are the same thing, which means that you take your n and you divide it equally amongst all the categories. So I'll take my n of 300 and divide by how many categories I have, because then that way they all get the same amount, split equally. So that's how you compute your expected values. Either you're going to be given it percentages, and we multiply them by n to get your expected value for that section, or I'll say equally likely or no preference, which means that they all get the same amount. You just take your n and you divide it equally. So that's how you find your expected value. You calculate it for this one. Chi-squared matrix is 11.2. So that's the contingency tables, right? So that's like the test of independence or homogeneity of proportions, which are the same tests. And so you're going to look at your data, and you're going to see it's going to be a matrix. Again, it's going to be categories, but now you're going to have categories both on the top and the side. So you have categories here and here. The list, you're only going to have categories across the top, and you'll have observed and expecteds over here, right? So that's different. That's why that's different. Here you're going to have categories across the top and categories along the side, because you have two variables. In other words, you know two things about them. What kind of puppy are you? Well, I'm a yellow lab and I'm a female. You know two things about them, and they're not numbers, they're categories, or they're labels. I'm a yellow lab and I'm female. That's not the same thing. You wouldn't say, well, what kind of puppy are you? Well, I'm 7 and I'm, what's your gender? Oh, 12. Yeah, they're not numbers, they're categories. All right, so this one, 11.2, is really easy to spot because it has categories both on top and along the side, both. That's the way you make your matrix. Categories across the side, you have rows and columns, R's and C's. Your expected value is a little bit different. Remember, with 11.1, you have the percentages that you multiply by n, or you divide n equally amongst all the categories. This one's different. To calculate your expecteds, first of all, I'm not going to make you do all 6 of them or all 12 of them or whatever it is. I'm only going to make you do the first one and the last one. And the way you do it is you take your row sum, multiply by your column sum, and divide by the grand total. And then the chi-squared, the test stat, is the same formula. However, I'm not going to make you do that by hand or write the formula out because you already did that in chapter 11.1. Instead, I'm going to use stat test chi-squared test to do it. So here are the steps. Step 1, H naught is O sub I equals E sub I. H naught is O sub I equals E sub I. H1 is O sub I is not equal to E sub I. Step 2, find your critical value from the chi-squared table. Draw your picture, shade, put in your critical value. Step 3, find your first and last expected value. So my first one, E11, row 1, column 1, remember it goes RC, is going to be, it's his. So it's going to be my rows total times my column total divided by my grand total. And that's going to be the expected value there. You're also going to have to find it for this guy here. He's going to be, he is row 2, column 3. So it's going to be E of 2, comma 3. And you're going to do the same thing to find as you did here to find his expected value. And then for the chi-squared, for the test stat, you're just going to make it real easy. You're just going to do stat test, chi-squared test of matrix A. So you're going to put your data here into matrix A, and then it's going to store it and output the expected values all into matrix B. You don't have to put anything in the matrix B. The program will do that for you. And then it's also going to give you your chi-squared number and your p-value, which is what you're going to put. Your chi-squared number is going to be what you stick into here. Step 4 is the same as everything else, right? If it's in the guilty region, you reject H naught. If it's in the non-guilty region, you do not reject H naught. And then last, step 5 is blank evidence that proportions are equal. So either you have enough or you do not have enough evidence. Blank evidence that the proportions are equal. That's all you got to put. I don't care. You don't have to be fancy, nothing else. Just that's good enough for the exam. For the homework due tonight, it's a little more complicated. Right? You've got to pay attention to some other stuff. And you can do the fancy one in the exam too. I don't care. But this is the bare minimum you need to do is that. Good. Chapter 11.3, ANOVA. That's the straightforward one. You're testing that means are equal. And it's complicated to compute, so we're just going to use the TI-8384 to get the results, and we're going to grab the p-value from there. And remember, p-value is the probability of getting a sample like yours. If your sample is unlikely, it will have a small p-value, right? So what's our guideline for unusual again? Remember, guideline for unusual, if its probability is what? 5% or less, exactly. So 5% or less, because usually alpha is 5% as a default. So if I don't give you alpha, it's 5%. But sometimes alpha can be other numbers. They might set that. So if it's alpha or less, then it's unusual. So if p-value is alpha or less, it's unusual. We're going to reject the null hypothesis. You got something unusual. If p-value is greater than alpha, then it's not unusual. H naught could possibly be true. So you do not reject the null hypothesis. So remember, this one's a little bit different. This is that whole kind of unusual. It's the opposite of what we've been doing. That's the whole p-value low, H naught must go. It's just going to freeze up on me. Didn't write down, didn't keep any of the stuff I just typed either. Value low, H naught must go. P-value high, H naught will fly. In other words, it's good. Okay. The other thing we're going to talk about a little bit is the between group variance and the within group variance. So what this test does is a lot of it is it compares these ratios, the between group variance and the within group variance. Now it's the between variance and the within variance. So what are those? So again, remember these first graders and fourth graders and 12th graders from last class. The first graders, let me get back to me. There we go. So the first graders, their heights are going to be like this, somewhere in here. The fourth graders, their heights are going to be somewhere in here. And 12th graders, heights are going to be somewhere in here. So their variances are going to be like that much, right, for each group. But the within group variance, between the groups, within group variance is, the between group variance between each other is going to be a lot bigger because it's between the different groups. Within the group, it's only going to be this much or that much. So within group is going to be is this part here. The between groups is this part here. So you're going to take your between group variance and divide by your within group variance. Try to catch me if I say something totally wrong because I'm subject to doing that today and apparently I'm very tired. Okay, so that's the F value. It's the variance between, or the between something variance, between group or between sample variance, divided by the within group or within sample variance. So you'll find one that will talk about variance between and one that will talk about variance within, and you're going to take the between one and divide by the within one. So you should write down that formula because you're going to need this. It's separate from the ANOVA test I will give you. I'll give you an ANOVA test, hypothesis test, and you just do the whole 5 steps like we just talked about. This is going to be a completely different problem. And I'm just going to ask you, hey, here's some between group variance. The between group variance is blah, blah, blah. The within group variance is blah, blah, blah. The alpha is this. This other is that. You know, the sample size N1 is this or whatever. And I'll say, compute the F statistic. And all you got to do is just divide these two. That's it. Super, super straightforward. But I want you guys to realize the reason why I'm doing this is because we didn't really do any of the hard work of ANOVA. So I want you to at least realize that it comes from the fact that we're comparing the between sample variance and the within sample variance. So in other words, if they're all about the same, right? If their variance here between each group is the same as within the group, if the within group variance is the same, that means that their means must all be the same. They can't be a mean up here and a mean down here, because if there's a mean up here and a mean down here, then the between group variance would be really big. But if the within group variance, if they vary about as much within one group as they do, you know, between each other, then like say they're like this, then their means are kind of the same, right? Because if his within group is here and his within group is here, and the between is, you know, from here to here, that's pretty close. So their means could be similar, but you know, if they're far apart, then the between is going to be a lot bigger. All right, so here are your steps summarized for this. How about, who hasn't read in a while? Derek. I don't think you've read in a while. Derek, can you read? I can't remember if you have it broken, if you're the one of the people with the broken microphone. Okay, I think you might have a broken microphone. How is Soraya? I don't think you've read for a while.
Okay. S21, the state-based hypothesis. H naught, mu 1 equals mu 2.
And so forth, yeah. So all the mu's are equal.
H1 as if one of them is different from the other one.
Right. So sorry, I'm going to jump in for a quick second. So you can't say that mu1 is not equal to mu2. Is not equal to mu2 because you don't know which one is different. Mu1 might be the same as mu2, but mu3 is different. You don't know which one differs. So all you can say is at least one differs. Keep going. Yep, so just write it down. Keep going.
Put the first loop into L1, next into L2, last into L3. Start step ANOVA.
Yep.
L1, L2, and L3.
Great. Don't forget commas in between them.
Step 4, make decision to reject H naught or not. Step 3,
Blank.
evidence that things are the same.
Yep. Thank you so much. That's all you got to do. Blank is either it is or is not enough evidence that the means are the same. That's it. Super straightforward on your summary. That's all you got to do. Good? Questions? I can't really read my chat because for some reason it's not coming up. I don't know why. Okay. Good. So let's take a look and compare. Yeah. Question? Good. Yay. Good. All right. So this is I slightly revised this from last time a little bit to emphasize a couple different things. So these are the kind of the three main types of problems we have. This middle one has kind of two subtypes within it. Chapter 10, that's the correlation regression. So the word correlation or regression might come in there, or linear relationship, linear, right? That might come in there as well. But it's when you have two variables and they're numerical data, right? Like number of cars you own for your rental agency and the income, your revenue. And those are going to be numbers, right? How many cars do you own? You're not going to say purple. It's going to be a number. And they're going to end up in lists, two lists that are X comma Y. They're going to be paired up lists. This one down here, chi-squared, that's 11.1 and 11.2. The chi-squared list is 11.1, and that's where you just get, well, first let's talk about all of them. Chi-squareds in general are going to be frequencies that are in categories. So your data is going to be a category. So the questions that people are going to ask, the answers are going to be categories, like, you know, what color shirt do you wear, and are you wearing, what kind of pants are you wearing? So you might say, oh, I'm wearing jeans and a red shirt. So that you go under the red shirt section up here, and then you go into the jeans section on the second part. Or what kind of puppy are you? Oh, I'm a yellow lab and I'm a female. So that would be their answers, right? Those are labels. Yellow, they're a yellow lab, and they're female. That's their gender. So then they go to that section. They put a little tally mark into yellow female, and then you count the tally marks for each section, and that's kind of your count, your frequency. So you're talking about frequencies and categories. And we're comparing observed and expected. So you're going to be given the observed, and you have to calculate the expecteds. And this is just going to be a list of numbers, just one list, one variable, one list. And then this one is going to be a matrix. It's going to have two variables. So you're going to have categories across the top and along the sides. This one's only going to have categories across one direction. This one will have categories across the top and the side as well. And you kind of see the data is in here making a nice matrix. The third thing is 11.3, ANOVA. Right, that's multiple lists, and you just want to see if their means are different. That's going to be the test at ANOVA. So ANOVA, and again, the word means or average will probably be in there, because you're comparing means or averages. Means and average are the same thing. And this is that table I did for you guys last night. Right, so you kind of see how many variables you have. If you have two variables, then are the answers to the variables numbers or categories? If they're numbers, then it should be a linear regression. You should be using the PPMC table in R, and they should be in pairs of data. If they're categories, if the answers to the variables are categories, then that's a chi-squared matrix. Again, you should have frequencies and proportions in there, and expected and observed values. You're given the observed, you need to calculate the expecteds. If it's only one variable you're talking about, then it can either be a category or a number. If it's categorical, then again, that's a list. You're going to, the answers are lists. That you have labels there, and again, they'll be either frequencies or proportions, and you have to calculate your expected values. If it is a number, then if the answers are numbers, then you're going to have three different lists, three or more lists, and they're going to talk about means. And we're going to compare p-values this time. That's an ANOVA one. So sometimes it gets a little bit confusing because it's not like there aren't numbers here, but your answers aren't numbers. Your answers are categories. Answers to the questions are categories. Here the answer to the questions are numbers. And we'll see a few of them in a minute. Or actually, here's one. We'll go back. Like, for example, this one, types of shopping. Respondents said they use reusable shopping bags. So in other words, what question was asked of them? What kind of shopping bag do you use? Right? And yes, there is a number, 28, said paper, but that doesn't mean that their answer was 28. Their answer was paper. How many of them said paper was the number. This is a frequency. This is not the answer. The answer was paper. I use paper. That was their answer. So the answer is a category. All right, so then you guys, go ahead. This is, again, from last time. take 30 seconds or a minute and try to figure out which one of these is which.